Hi everyone. So in today's video I would like to discuss the configuration of the ESMValTool on Gadi. So if you use the module provided in XP65, so the ESMValTool module, it already comes pre-configured to use the main NCI data collection for CMIP 6.5. And it also links to some reanalysis like ERA 5 and observational datasets like the ACCESS-NRI collection for observational datasets used for model evaluation. So you're basically already all set to run most of recipes available via ESMValTool, and you don't have to do anything. But that being said, you may want to slightly change the configuration, and so we're gonna have a look at this together today. So just like quickly starting from the ESMValTool website and the documentation, just want to point out to the documentation and show you that in the getting started section there's a subsection called configuration, where they basically explain you how to get the default configuration. So if you run this on Gadi, you will get the default configuration for Gadi that we've pre-configured for you. And they also so if you want to go in like more details about how you write a configuration file, you can click here and have a read. But hopefully we'll have a look at this together today. And another thing that they mention is to read the section on finding data. So that's actually quite useful because it gives you a bit of background on how ESMValTool finds data on the system. So having a bit of knowledge around this is very useful when you start developing recipes. But again, we'll go through this together today. Okay, so first thing we want to do is to start a terminal and go on Gadi. Here we go, and I'm going to request an interactive job. Alright, so I now have an interactive session, so I can load the module. And we are ready to go. So first time you run ESMValTool, so the tool will use the default configurator file. But if you want to modify it, a good idea is to get a local copy on your system. So it would be done using that command, get config user. And what that command is going to do is it's going to copy the default config user file into the .ESMValTool folder in your home directory. So if I go to my home directory, ESMValTool, I can open the config user file using my text editor. Okay, and here we go. So we've got, I'm just going to make this a bit bigger. Was not necessary apparently. Okay, this is the configuration file that ships with the module. So it's heavily documented, and I encourage you to have a read. But we're going to go through the different things you can modify. So the first thing is the output directory. that is by default set to be ESMValTool output and will be created in the working directory. This is fine in most cases. I encourage you to change it to use the Scratch system on Geddy when you can, because potentially has quite a lot of outputs. So you don't want to run this in on the logging node. Definitely, you don't want that output to be on one of the logging nodes, and you may not want to have it stored on GData. Scratch is good because it's fast. It's also cleaned regularly, so it's a good good space to work. So for example, we could change this to use, in my case, I use the IQ82 project. So that's my login on Geddy. So we could use something like this. All right. The next one is the auxiliary data directory. So auxiliary data means like pretty much everything that the recipes might need, and that is non-standard, like things such as shapefiles, could be CSV file, but some data you may want to have access to, like to run your recipe. So it's very recipe dependent. Typical things is to use Cartopy data, like so shapefiles, or country borders, things like that. So by default, we've downloaded quite a bit, and we've put them in that public folder on XP65. The next parameter is the search ESGF that can be set to so you've got different options there. So what is it? So every time ESMValTool cannot find a dataset, it tries to get it from the Earth System Grid Federation. So that's for CMIP data, obviously, or ops for MIP too. So you can set that parameter to be when missing, so it will only look at search for data when it's not available on Geddy. You can set it to never. In that case, you turn the option off. Or you can set it to always, and in that case, it will check the version of the dataset and try to make sure that you always use the latest version. So this is quite important. So that option is quite important because depending on which queue you're running on Geddy, you may get in trouble, right? Because not all the queues on Geddy have access to the internet. Actually, only a few of them have access. CopyQ is one of them, but CopyQ has computing restriction, like you cannot request for much compute resources. So for most of the recipes that ship with ESMValTool already have all the data needed on Geddy. So if you could use never here, and you should be fine. But if you want the tool to be able to grab data from the internet, you need to first make sure that your queue will have access to the internet, and you need to set that parameter to, I would say when missing is fine, or always, if you really want to make sure that you have the latest version. So just something to keep in mind. Yeah. So related to that search ESGF option, data downloaded from the internet will be stored in a specific directory. In that case, we set it to be climate data. Again, same for the output directory. This is going to be in your working directory. So you can change this to be on Scratch or GData if it's data that you think you will be using regularly. You have the option to set the number of maximum parallel tasks. So we will discuss like the parallel capabilities of ESMValTool in a more advanced video. But just keep in mind that you have that option here. I set it to null, so I'm just using what's available, and it works in most cases. Setting up the log level information that you get. So ESMValTool can be very verbose. It's often like too much information. So I set it to info. That's already quite a lot of information. But of course, if you want to debug a recipe, you have the option to set it to debug and or highlight warning errors. You have an option here. Some additional example for some additional things. If you're using an NCL script, you have the option of exiting on warning. We set it to false by default. And you can set the output file format. This is essentially for figures. Default is to create PNG files, but you could go for PDF, EPS. It's a good idea to use EPS if you want to modify things using software, vector software like Inkscape or Illustrator. Up to you. Remove preprocessor directory. So I will discuss in one of the next videos what you get as an output when you run a recipe. But just to explain what that option is here is, so you've got a series of preprocessors that can run on your datasets, and they will save intermediate netcdf files. So these files can be quite large, so you may or may want to keep them. So if you're more like space savvy, or up to you. So in that case, I set the remove preprocessor directory to true, which means I don't keep those files. You've got the option to use netcdf compression. It's set to false by default, so up to you. Again, option to save intermediary cubes in the preprocessor. So cubes, ESMValTool uses Iris, the Iris library. There's option to save intermediary cubes. Set it to false by default. I would suggest like having a look at the documentation if you think that you may need to save in those intermediate pre-processing steps. Path to a custom config developer file. All right. So this is for developers. So this is a file that I'm probably not going to show you today, but that's basically where we define the directory structure, all the DRS for the different projects like CMIP, Ops4MIP, etc. This is pre-configured for Gadi, so you don't have to use that. And again, that's quite advanced, so maybe I will go through these things in the video later on. You can run a profiler on your code to give you an idea of how it's performing. And so the next section is actually quite important. It's about the root paths. So when we talk about root paths, we mean so paths to the different projects. So ESMValTool thinks in terms of projects. So example of projects would be CMIP 5, CMIP 6, CMIP 3, Codex, Ops4MIPs. All these things may be in different like location on the system. So I've kept the default configuration that have just been commented here and in that folder for the different system that ESMValTool has been installed where ESMValTool has been installed. So you've got like things like DKRZ or ETH Zurich, things like that. So this is commented, sorry. And so if you go down, you will see the last entry is for the last set of entries, sorry, is for NCI. Let me just reopen this so it's a bit easier to read. Yeah. All right, that's gonna have to do. Sorry. Yeah. So these are the root path for all the different projects: CMIP6, CMIP5, CMIP3, OPS, OPS6, OPS for MIPS, and ANA for MIPS. So CMIP6 and CMIP5, I guess you know what these are. So we point to the root of the different NCI data collections available for CMIP in that case. So you've got the OR I10 project, the FS38 project, which is published access models, I believe. And I've added like some an extra path that you don't have to worry much about this. It's just another location for missing datasets. Same for CMIP5, so we link to R87, L33, RR3. Okay, so the tool, when the tool is running, it will try to find data depending on a project key that you use in your recipes. So each dataset is defined with a set of keywords, one of them being the project. So if you use the CMIP6 keyword for your project, the tool will go through the root of those directories, through those root directories, sorry, and we start looking for the data set. So it's basically telling it like I need the CMIP6 data set. Here is the root of my CMIP6 project on NCI. The tool already knows about the DRS using the developer configuration file that you don't have to worry about, but it's basically a CMIP DRS in that case, and it will find the data for you. Same for CMIP3. CMIP3 has a directory structure that is a bit looser than the CMIP 6 and 5, but it's the same idea. For observational dataset, so we these are stored in the CT11 data collection, which is the ACCESS-NRI collection, replica collection for model evaluation. So the ESMValTool recipes differentiate between OPS project and OPS6 project. OPS is basically observational data sets that are compatible with CMIP5. So CMIP5 metadata, CMOR conventions if you want, in the context of CMIP5. And OPS6 is compatible with CMIP6, obviously. Yep. But I mean, if you have access to CT11, feel free to have a look at what's available there. We will have videos to explain these things a bit on the track. Of course, there's like other projects, like typical projects are OPS for MIPS, ANA for MIPS. Again, we link them to CT11. We may add more, like depending on like as we go, and we find like interesting data sets like available at NCI. Last entry is for raw observation. This is mainly for ACCESS-NRI usage only, so you don't have to worry about that. And but there's an option to have raw data sets as well and use ESMValTool as a summarizer. Again, I'll discuss these things in another video. The DRS for each project, here I've defined CMIP 6, 5, and 3 to be NCI DRS. NCI follows the CMIP convention for the DRS, so that's a normal DRS, but we could have like other options. You don't have to worry too much about this. Codecs, I haven't talked much about codecs. We don't have support for codecs right now, but it's coming, and uses an ESGF DRS. Ops for MIP and ALA for MIPs are set to default. Again, these keywords here refer to the developer config file, but you can have a look at if you want, but it's really not needed. All right, and that's basically all that's needed. So I will say that everything above the root path is just simple options that you can configure on when you just like to slightly change the way the tool behaves. You don't have to worry too much about the root path, but you may want to, if you have, let's say, like some specific data sets that you've downloaded from ESGF in one of your research projects that you want to link to, that you can add the root path to one of those projects. All right, so that's the config file. So you also have the option to pass any of those configuration parameters directly on the command line by passing them like this. So for example, I can do search ESGF when missing, or any other options, and just pass the name of the recipe and run it. All right, and that's pretty much it for today. Thank you.